everyone. Welcome to Big MiniConf. Thanks to all of you out there on the internets for taking the time out of your sunny Saturday afternoon to attend the talks that our grads have put together to share with you. So my name is Heather. I am the program manager here at the Immersive at Chrysalis, and I will be providing English commentary. And following me is going to be my amazing colleague Eriko, who will be commenting in Japanese.
皆さん、こんにちは。ビッグミニコンフにご参加いただきありがとうございます。今日はイマーシブクラスの卒業生によるテックトークを皆さんにお届けします。私は日本語イマーシブクラスのインストラクターを務めておりますエリコと申します。今日は私が日本語で、そしてヘザーが英語で MC を務めさせていただきますので、どうぞよろしくお願いいたします。
Okay, so let's just jump right in. First up, we have Miku Sano, who will be presenting us a tech-based solution to a very real problem that we face here in Japan.
では、早速一人目のプレゼンテーターをご紹介します。トップバッターを飾ってくれるのは佐野美久さんです。彼女は日本が直面している問題をテックの力で解決する方法を紹介してくれます。それではどうぞ、美久さんよろしくお願いします。
Thank you for introduction. I'm going to share my screen now. All right. Hi, everyone. My name is Miku. Today, I'm going to talk about remote care with wearable monitoring devices. I am a software engineer with a background in nursing. I've been working in a clinic for 7 years, mostly in a diabetes department. My path to software engineering began while I was working as a nurse, where I found the passion to become an engineer and the possibility of using more technology to support people in health. My interest is creating things to make others' lives healthier and the different technologies that come along with it. I'm from Fukushima Prefecture, currently based in Tokyo. My mother lives in Fukushima. Actually, she is the one who gave me an idea about the topic today. My mother is an independent, great lady. She raised me and my younger brother by herself after the passing of my father. She is in good health, enjoy life with her body, a golden retriever. I call to her every weekend, but I'm having concerns about my mother because, like everyone else, she is aging. Who does have a family in remote area? Thank you. I think living far away from parents is a common situation for many people. This brings us to issues. The first, there is rapid change in household structure in Japan. In Tokyo, 42.3% of singles are over 65 years old. Second, the community is changing. With the changing of household structure, the connection with families and communities are changed as well. Third, that means there is a possibility of finding emergencies. Fourth, healthcare professionals work very hard, but actually there is a lack of human resources. As a daughter of a mother who lives in a remote area, I think it would be nice if I had a device which allows me to gently watch over my lovely mother? A Fitbit, wearable monitoring item, is an option. It gives you a variety of data with frequent updates. In this presentation, I'm going to talk about Fitbit, then show you demo, talk about merit of using Fitbit, about Fitbit API, and challenges. So, what is Fitbit? Who have heard about Fitbit? Thank you. Fitbit is a fitness tracker. For instance, I like having outdoor activities like running and cycling. I always wear a Fitbit because recording a spending amount of time for activity gives me good motivation. Not only that, Fitbit has many functions. For instance, counting steps, calculating distance traveled. So, my idea is getting specific information from Fitbit and visualizing the data on a chart. It is possible to query for certain metrics and answer questions. In this way, you can analyze and plot the data using your own tools to uncover trends that the Fitbit-generated charts may not show. So, this is a chart I made. On the left, you can see the steps by minutes and calories out by minutes today. It's my data. I'm not so active today. And right side, you can see the summary of steps, weekly summary of steps and activities. Let's have a close look. So, like this, you can see how many steps are counted every minute, and you can see how many calories are consumed every minute. And this is a close look of summarized data of steps and activities. When you point out the cursor, you can see more detail about each data. All right, structures. I used Python to implement the code, and I used Google Cloud Platform to visualize data. A brief explanation about the mechanism. How does Fitbit count steps taken? Fitbit features a 3-axis accelerometer. They can tell when they are moving forward and backward, side to side, and up or down. The Fitbit uses algorithms to tell when you are in motion on your own 2 feet or are moving your arms but overall motionless. By implementing the movement data recorded, your Fitbit can tell if you are walking along or simply tapping your hand on a desk. As a Fitbit user, I'd like to emphasize 2 points about the benefit of using Fitbit as wearable monitoring item. The first is continuous monitoring. The monitoring device keeps tracking the amount of activity continuously, so users don't require extra work. The second is accuracy. Imagine if the person falls down on the floor and moves his or her hands to ask for help, and if the movement is counted as steps. Fitbit, a 3-axis accelerometer, gives reliable activity data. And as a developer, I think Fitbit has 4 merits. The first, easy to develop for. Fitbit API, the access points are opened, so everyone can use the data of their own Fitbit. The second, easy for users. Just only wear that device. No complication makes it easier for users to accept that device. The third, using Fitbit is cost-friendly. In general, Fitbit is available from around 10,000 yen. No extra device needed. And last, Fitbit provides various data, from steps to length of sleep. I'm going to show you detail later. Fitbit provides a web API. Everyone can access and modify a Fitbit user's data on their behalf. Quick start. First, register your application to get API client credentials. You will need a Fitbit account to register an app. Second, implement an authorization to allow people to give your app permission to access data on their behalf. And last, make requests to access data. The different types of data available via the web API listed in the navigation. These are examples of available data. We can get the data of activity and rest, and both data provides summarized data and data per certain intervals. These are activities. I might be interested in the summary of the amount of the time my mother spends having a shit, because as physiological change in the age of my mother, depression is a common one. So certain period of less activity could reflect her mental health. In addition, heart rate is available only by specific Fitbit device. These are sleep. For example, if the person has urination disorder, it is also a common condition for most aging people. Awake count will help to analyze the situation, especially after starting medication, to monitor how effective the medicine is. Challenges. In the whole procedure, authentication is a very important part. Actually, it was the most struggling part for me. I started from researching about technical terms. Let's see the definition of these words. What is OAuth? From Wikipedia, OAuth is an open standard for access delegation, commonly used as a way for Internet users to grant websites or applications access to their information on other websites, but without giving them the password. In this case, Internet users are you. Application is the application we will create to access data. The information is your Fitbit data. Other websites are the Fitbit platform. Using auth allows me to access the app without making sure my identity every time. What is access token? Access tokens are issued to the third-party client by an authorization server with the approval of the resource owner. Access token is like a personal key to the app. We will obtain access tokens from Fitbit with your approval to access the data. In default, an access token, the token given by Fitbit after registering your Fitbit app, is going to expire in 8 hours. Python Fitbit module refreshes the token, but it doesn't save it. So I implemented the code like if the authentication is expired, refresh access token and refresh token, then update them. We live in an unpredictable period, changing family structure, changing community, changing the value towards the life. I like a message from Mother Teresa. I can do things you cannot. You can do things I cannot. Together, we can do great things. Technology helps us, like this small monitoring app. It allows us to support the family and the community with a variety of choices. I dedicate this presentation to my mother, who gave me an initial idea of this talk. I might not present here today without her great effort. Thank you for listening. You can find my repository here at GitHub. If you'd like to chat more about Fitbit API or the project, feel free to reach me at my email or social media. Thank you.
Okay, Miku, wonderful presentation. Thank you so much. I'm sure that everyone enjoyed that as much as we did. So to everyone out there, this concludes our first presentation. The next talk is going to begin at 1:30, so grab a snack, stretch your body, and come back here at 1:30.
ミクさん、ありがとうございました。素敵なプレゼンテーションでした。では次のテックトークは1時30分からスタートします。ですので、また1時30分にお会いしましょう。ではまた後ほど。バイバイ。
Okay, welcome back, Big MiniConf attendees. So up next, we have Yusuke Yamada, and he's going to be demoing a Line app that he built using the Line API.
それでは次のプレゼンテーターは山田祐介さんです。彼は LINE API を使って LINE のアプリを作ってくれたようです。どんなアプリを作ったのか楽しみですね。では、祐介よろしくお願いします。
Thank you. Thank you so much, Heather and Eriko. Let me share my screen. Okay. Can you guys hear me? Are you okay? Yep. Okay, so I'm going to talk about building a mini app with Line API. So today's goal is to learn what is an API, just get a brief idea of what it is, and learn how to use them. And hopefully you can create your own app using an API. So before we get started, I would like to introduce you to myself. I am Yusuke. I'm a software engineer in Tokyo. I love traveling, and I have backpacked around 20 plus countries in the world. And I am a big fan of sushi, and this is my favorite food. And that is me on the left. And on the right, there is Miku, who presented the previous presentation. And this was held in Halloween at Chrysalis. So that is me. And why did I choose this topic about API, or specifically about Line API? So a story of my API is not like a giant story of my life or anything like that. But when I started learning code in Chrysalis, I discovered what is an API is. I have never used it. I didn't know anything about API. And it was pretty amazing that you could do many things. You could collect data. You could use other people's programs and use it or integrate it with your own program. And I thought API was really cool. So this really got me interested in talking this topic to you today. So actually, this is the first app that I've made during Code Chrysalis. This was, I believe, the first time I've learned API and used them and actually build an app. It is really a simple minimum app, but it was, at the time, it was really amazing that I could use them and create my own application. So this is just a basic book search where I search books and add it to my favorites. And it was amazing. So I've been talking about this API stuff, and this topic or this presentation is mostly focused on people who want to use API or learning to use API, or maybe even first time learning code. So before I get more deeper or going through the rest of the presentation, I would like to talk to you about what is an API in general. So API is an application program interface, is a computing interface which defines interaction between multiple software intermediaries, blah, blah, blah from Wikipedia. And I hate this terminology. The first time I heard it, it was horrible. I don't really understand what was application program meant. And even what do you mean really by interface? Like, does software has interface? Does program have interface in it? So I do not like this terminology. So let's take a real world example. And if there was an API or convert it into an example in a real world, what would it like it to be? So this is just one of the examples that I personally like to define API. So let's say you're in a restaurant and you are super hungry, right? And you're the poor guy, the poor emoji on the left, and there's a bell that you could ask an order to food, and the chef will cook the meal with an order that was given and give you back the food, and you're happy. So this is kind of like the API. I mean, you get happy, but that's not the point. So API could be something like you're a program, or you write program that is, the bell could be like an interface that allows you to make a request to a different program, and they will give you back a response. So let's take a look at what would it like it to be in a software world example. So like the example that I mentioned, or the app that I made in the beginning when I learned API, the book search application. Let's make a example during that. So let's say you search a book, you make a request to a server, and the server give you back a response. That is it. It's just simple. It is. But let's say, because you're a software, you write code that make a request to some kind of API. In this case, what I was using was Google API. So the Google API allows me to get some kind of data and give me back a response. So let's say what is happening behind the scenes is that when you search a book, my program runs or executes, and it will make a request to a server. Then the server will interact with an API, getting some kind of data from a Google, in this case, gives me back a response, and I serve back that data. And this is just it. So anyways, do you guys know what is line? I hope you understand what I'm talking about with these, what I'm talking to you when I say line app. If you haven't used it, you're missing some good stuff in life. Okay, so line is a daily use app. I use it every day. People in Japan mostly use this messaging app all the time, and 70% of the people in Japan use this. So that's like most of us, except for like babies or who doesn't have a smartphone maybe. And I was really interested about Line because in the beginning, it was just a messaging app, same thing as like a Facebook Messenger or a WeChat or WhatsApp. But they started growing and making these integrated apps inside of a messaging app. So this is what got me really interested in Line. And one of the examples, specifically, I got really interested or got excited was these Yamato Transport official accounts that was inside of a Line app. So it gives you a notification when the item is at your house, delivered at your house, or you could even change time or day when you want it to be delivered, or you could arrange a redelivery. So before we had this, there was when you're not at home, they will write a paper and put it on front of your door and says, "Call me back when you're ready." And this was a problem because when you're back from home and you try to call them and ask them to arrange a redelivery, they're not open. So when this came, it was 24 hours that you could have a connection or make a request to Yamato about delivering items from maybe like an Amazon products that you bought. So this is how the Yamato app looks like. And there's more examples other than Yamato. So one of the things is that Line Corporation made an app together with Ichikawa City that they could get a residence card. So when you want to get a resident previously, you had to go to the city hall, wait a long line. Maybe you could only even go on Saturdays or Sundays. But because of this, you could just use your line and text a message saying, I want a residence card, and deliver at my home. And you could make a payment just with your credit card. Or in this case, Line Pay is their payment system they have integrated. Another example is you could check your bank balance through Line. This is kind of crazy. You would mostly check your balance, I would say, in your ADN, or go to the bank, or maybe if there, you could check through online and type in password or something like that. But because of this, you could just say, hey, how much balance do I have? And they give you back a response and give you data that which day you had transactions. And this was pretty cool. And this is not just on the Line app, the integrated app is not just these big companies that has them. You could also make them. And one of the example is this Moji Okoshi. So this app is called Moji Okoshi Barigutto. It's a funny name. But what it does is you send an image and it analyzes the image and it transcribes what is on the image and reply within text. So it's like this. You send an image that wants have a transcription or translates through a text from an image and send it back to you. And this was pretty neat. And one of the things, this is not like the corporate people that made this. It was just a single developer, I believe, that made this. So it's not just those big companies that can make these integrated apps into Line. Okay, so I've been talking about this, what is Line and what is API. So you could use these kind of, or make these integrated apps with an API that Line provides us. So I want to introduce or talk about what is actually a Line API is. So there are several things that Line API provide us. One of the things is Line login. So this is just like Google login. You have like signing with Google, or maybe signing with Twitter or Facebook. Line provides these kind of things. Also, other things are like Line Notify. Let's say if you have a favorite blog site, and whenever they make a new post, you want notification, you make an app and get a notification. Or maybe if you're a developer, when somebody make a pull request, you get notification. You could make these kind of things with Line Notify API. And other one is Line Pay. You could integrate Line, use their Line payment system. Let's say you make an EC site and let the users pay through Line Pay. You could use the Line Pay. So today, there's many APIs that Line provides us, but today I want to talk about, or I'm going to introduce you about a Line messaging API. So just an overview. Line messaging API builds a bot that provides personal experience for the users. Bot associate with a channel on the Line platform, and bot works behind Line official account. Okay, so Line messaging API can reply messages, push messages, and get contents by user. So let's see how that works. So how it works is that Line messaging API allows data to pass a data between a bot server and through the Line platform. So let's look at some diagrams. This is how it works. So when you push or send a message, the Line API connects or interact with your server. Sometimes you could have a database and reply a data or message through a messaging API and send it back to your Line app. And Line API provides two things. The bot could send a message by themselves, or it responds or reacts to whatever the user sent a message. So let's see some demos that I've made. I'm going to unshare my screen and share how the Line bot is working from my iPhone. So please hold on a second to switch a screen. Just a second. Okay. Okay, so right now I have nothing in here. So before I get to demo, I'll just explain what this do. So I will send some kind of text and the bot will respond. That is just simple it is. So let's say I just say Python, and it will make a response to my bot server and make a request to, in this case, Amazon, and get all the highest rates that all the products that has a high rate in Amazon, and giving back a response with a link. So in this case, it says results for Python. So it gives me back a link. When I click it, there's all the highest links or the items that are in Amazon. And this is possible because we're using Line messaging API. It's a simple app, but you could integrate something inside of your Line and make your personal app inside it. You don't have to make a native app, iOS app, or Android app. You could use their API and make an app on top of their platform. So this is just a simple example to create your own app. Okay, so let me go back to my screen. Okay. Oh, so how did I create this? So let's see how the tech stack or the workflow of this app. So what's happening behind the scenes? It's really simple. You send a text, and the messaging API connects to my bot server, and I have a program running with a Python, which are hosted on Heroku, and getting or requesting a data from Amazon and getting a response from Amazon, and letting the messaging API connect with my server again and replying the message back to my Line app. This is just a simple workflow, and this is the simplest way, or how you can see how simple it is using their API. Okay, so there's many ideas probably you could come up with, but I would share some kind of ideas. Maybe you could after this presentation, you could work on. So some ideas could be maybe company expensive management. Oh, so this is like, let's say you're in a company, you had a meeting with some kind of your negotiation company or something like that, and you had lunch with them, and that expense goes to your company. So most of the time, well, at least in my former work, I used to have to get a receipt and provide them with why I why I need to make, or why I have to make this on company expense. I had to write a paper or something like that. So this is kind of annoying. So there's an idea that you could make app with this, just sending a picture image of the receipt and sending it to a bot server and allowing the bot server to maybe analyze it and write or calculate the expenses and put the data on a spreadsheet or something like that, and just automating everything. Another example is like daily schedule reminder. Since we have Google Calendar, maybe this is not necessary, but maybe you could use this to have a reminder daily schedule, just not from the Google app, but through your line every day or every hour or before the schedule starts. This will be a more simple idea, but you could have that. Other things you might have is automating shopping. So the demo I showed was getting the data or the items from the Amazon, but maybe you could have an app that collects items from even Amazon, Rakuten, or Mercari, or eBay, or any kind of EC shopping site. And whatever you search or text from your line, it collects or compares the best ratings, the best stars, and the cheapest item. And you could maybe pay automatically just texting from your line app. So these are some ideas maybe you could work on. Okay, so conclusion. This is what I've talked in the beginning. Hope you learn or briefly understand what is an API, learn how to use them. Hopefully you got some kind of example or ideas. And hopefully you can create your app with some kind of API that are provided somewhere online. There's many things that could be talked in API. And when we talk about API, mostly people will be talking about web-based API, but this is just an intro. So I will finish here, but you guys could hop on and go with an API and enter the API world, I would say. So thank you so much. You could scan the QR code and try the bot that I had demoed today. And I will get the repository public for you. And hopefully you can create your API through my repo. Thank you so much.
Okay, Yusuke, great work. I know that was a lot of useful ideas that you just shared with our audience there. So congrats on finishing your talk. That was amazing. So we're going to take a short break, and the next talk is going to begin at 2 o'clock.
ゆうすけさんありがとうございました。私も毎日 LINE 使ってるので、すごいこういうアプリがいっぱい出てくると嬉しいなと思ってます。はい。では、次のトークは2時から、2時ジャストから始めていきますので、また2時に皆さんここに集まってください。ではまた後ほど。バイバイ。
Thank you.
Okay, everyone, welcome back. So up next we have Hyunggu Hong, who is going to be giving us a general overview of AI and how it can be used by engineers and business people alike.
では、次のプレゼンターは本さんです。彼は AI とはどんな技術なのか、その技術を実際にどう使うのかという疑問について分かりやすく話をしてくれます。では、本さん、よろしくお願いします。
見えますか？皆さん、こんにちは。私、本と申します。今回、AI の概要についてちょっと話したいんですけど、ちょっと待ってくださいね。切りますね。OK。で、今回の、ターゲットとしては、こんなあなたに聞いてほしい。Who are the targets of this presentation? 一般の方ですね。もう AI が普及してきて、あんまり、なんですかね、テクニカルなことはみんな知らないと思うんですけど、これから絶対AI についての知識だったり、どう扱っていくかっていうのは、多分一般の方もこれから知る必要があると思うんですよね。で、その理由についてはこれからもお話しすると思うんですけど、絶対必要なんで、このテクトーク見てくれればと思います。あと、ソフトエンジニア。で、人工知能のことについてあんま詳しくなくても、今回のことは聞く価値があると思います。なんかもしデータサイエンティストとかになりたかったら、この、そのテクトークを聞いて、入り口となればと思います。あと、ビジネスサイドの方もそうですね。ビジネスしてるけど、いざ、実際 AI がどうお仕事に役立つかっていうのは、多分結構知識がないとわからないことなんで、今回のテクトークでは、じゃあ実際 AI が何ができて、どういうビジネスに役に立たせることができるのかっていうのをお話したいと思います。じゃあ、次ですね。で、今回ですね、ちょっと特別に、なんて言うんでしょう。普通テクトークって一人でやるんですけど、ちょっとどうしても僕の力不足のせいで、アシスタントっていうのをちょっと雇ったんです。で、その方について紹介したいと思います。どうぞ。あれ、ちょっとクリスの調子が悪いみたいなんで、クリスっていう、AI を利用した、ロボットを今回、サポーターとしてちょっと雇ったんで、今回多分このプレゼンでも何人か登場すると思うんでよろしくお願いします。で、次にですね、まず、本格的に始める前に、このビデオを見てほしいんですよね。ちょっと、だいたい、1分ないぐらいなんで、ちょっと一回見てもらえますか。よろしくお願いします。ありがとうございました。実は、これ最後ら辺分かったと思うんですけど、この偽動画で、これすごくないですか？ 実は、オバマ大統領今出てたんですけど、今、なんかトランプはアホだとか、今動画で言ってたんですけど、これ一切言ってなくて、もう個人的には言ってるかもしれないですけど、一応このオフィシャルな動画では本当は言ってなくて、これ全部作られてるもんなんですよね。で、これがちょっと流行った2018年に作られたんですけど、この技術、ディープフェイクって言われて、すごくその時、話題になった技術で、これ結構、見た感じは面白いんですけど、ものすごく問題も抱えてるんですね、一方で。で、これがどういうことかっていうのを今から説明します。そのディープフェイクって言って、人の顔の中身を、自由に、動かしたり、交換したりできる技術で、これなんか面白いけど、これってすごく、なんて言うんだろう、いろんなことに応用できて、もちろんいいことにも応用できる。例えば映画とかで俳優なしとか、例えばコンピュータグラフィックで、例えばモンスターの顔を動かしたり、人間みたいに動かしたりとかできるんですけど、一方でものすごくその犯罪性の高いことにも使えるんですね。一応、聞いてください。そうなんですよ。今、クリスが言ってきてもらった通り、この技術っていうのは、今言った通りなんですけど、ちょっと次の動画でいきますね。で、何が問題なのかと。What is the problem? 情報の操作性を高めるってことなんですよね。具体的に何かというと、政治。例えば、政治の選挙、アメリカとかで盛り上がると思うんですけど、今やったみたいに、オバマ大統領とか候補者が言ってないことを言った動画も作れるし、一方で、これ実際あったことなんですけど、トランプが、テレビ番組で卑猥なことを言ったんですね。で、言ったんですけど、後でそれをちょっと批判されたときに、いや、実はあれディープフェイクだっていう逆の嘘もついたんです。だからこういう、なんていうの、情報がどんどん信用できないものになる可能性があるっていうのを一個、私はすごい懸念しています。もう一つ。あと、詐欺犯罪ですね。例えば誘拐とか、例えば自分の娘を動画一つあれば、その娘の顔を利用して、誘拐されたなんか、お母さん助けてとかいう動画なんて簡単にもう作れちゃうってことなんです。だからあんま誘拐って身近に日本ではないかもしれない。世界で言うと誘拐ってまだまだあるし、そういった意味で犯罪ですごく使われる可能性が高いっていうことです。で、あとは、ポルノですね。ポルノで、実際、9割のフェイク、このフェイクビデオの9割がポルノで利用されてて、もう何も関係ない、例えば、芸能人だったりがそれで利用されて困ってるって事実があります。で、次。で、悪いことだけじゃないんですよね。この音楽最初もちょっと鳴ったと思うんですけど、
ほんさん、すみません。We can't hear your sound.
Oh, really?
Yes.
Oh, okay. But you can hear my voice?
Yep, your voice sounds good, but we can't hear your sound at all. Would you mind adjusting your settings?
Oh, okay. So, like video too? The Obama's video too? You couldn't
Yes.
hear?
It had subtitles, but yes, we couldn't hear.
Oh, okay. わかりました。OK です。なんかビデオが、聞こえないの、音声が聞こえないみたいなんで、ちょっと聞こえる程度これからビデオの音は考えないでやります。一応今これ説明しますと、この、エイバっていう会社が作ったテクノロジーで、ここ今流して聞こえないと思うんですけど、この音楽って全部 AI で作るやつの音楽で、これめっちゃ聞かしたかったんですけど、ものすごい、もう普通に聴いててもかっこいい音楽で、これ全部 AI が作り出したもので、そのさっき言ったディープフェイクみたいな悪いこともあるけど、一方でものすごくクリエイティブで、なんかすごい未来を期待させるようなことも、の面でも AI はものすごく発達しているということですね。じゃあ次行きます。じゃあ実際に、なんかいろんな複雑なことをやってるんですけど、何を実際どうできるかっていうのはちょっとわからないじゃないですか。なんか顔を変えたり、今みたいに音楽を作ったりする。大体できるっていうのはわかるんですけど、本当に実際できることっていうのは何かっていうのを大体今から説明したいと思います。 まず AI ができること。識別ですね。ものを、例えば音だったり、画像だったり、もう何でもいいです。コンピューターがそれをインプットできるものは、多分これから全部識別をこれからできるっていうのが一つの役割で AI ができることです。で、もう一つが、予測。データがあれば、未来の、例えばこれからどうなるかっていうのを過去のものから、予測できると。天気予報だったり、いろいろこれからお見せするんですけど、そういう予測ができると。で、最後のもう一つが実行ですね。さっきAI が音楽を、聞こえなかったと思うんですけど、作ったっていうのをお伝えしたんですけど、実際にその予測とか識別の次の段階として、新しいこと、人間がやってきたことを実際やるっていう、実行するっていう、機能があります。じゃあ次ですね。ちょっと待ってください。最初の識別に関しては、フェイスレコグニション、が顔認識ですね。この顔認識っていうのが、これはもう結構有名になってると思うんですけど、誰がこの画像の中で顔の位置がどれで、この人が誰かっていうのまで、認識できると。じゃあ次行きましょう。で、次、ボイス。これもなんか皆さんスマートフォンで、結構使ってると思うし、例えば、あるかわかんないんですけど、家になんかアレクサというか、Amazon のアレクサだったら声に反応する。これも、音声認識の一つですね。で、もう一つ、これ結構面白いんですけど、エモーションリコグニションっていうのがあって、これはその人がハッピーとか、喜んでるとか喜んでないとか、サッととか悲しんでるとかっていうのまで顔の表情から識別するっていうのを、で次、予測。いってみましょう。これもすごいですよ。発がんリスク評価って言って、その人の、例えば、レントゲンだったり、検査で撮った画像を、とか、あと他の、今までのがんを患われた患者さんの写真とかを読み込まして、実際その人がどのぐらい、がんの可能性があるのかとか、これから発症する可能性があるかっていうのも調べられると。で、次、これは皆さんも経験されたことあると思うんですけど、Amazon 使ってたら、なんでこんな欲しいものを読んでくれるのみたいな、レコメンドが、画像、下の方に出てきたりするじゃないですか。それって実は別にどっかから情報を仕入れてるとかいうわけじゃなくて、その人の購買行動とかから、なんだろう、その人が次に何を買いたいかとかっていうのを AI で予測してくれるんですね。で、これがもう一つ。あと、出会いマッチングですね。あと、この人と、どういう人とマッチすればうまくいくんだろうとか、成功率が高いとかっていうのまで、わかるっていう。で、次行きましょう。次が実行ですね。最後、先ほどお見せした音楽と、あとさっきオバマ大統領の動画もそうですし、これエクスキューションって言って、人が実際作ってるようなこととか、実際なかったものを作成するっていうことができると。で、これもめちゃくちゃ有名なんですけど、自動運転ですね。これも、いろんなデータを、もうすごい何万何億っていうデータを読み込ましてから、実際に判断してるのはこの車っていうか AI なんですね。これは人間がやってきた五感を使ってやってきたことを今、車の中のAI が大体してる。で次に絵画ですね。この絵って、ものすごく有名な、人が描いた絵っぽいんですけど、実はこれ AI が描いたんですね。似たような画家がいるんですけど、その人の絵を 全部読み込まして、この人が描きそうな絵を AI に描いてもらったのがこうなったんです。これ多分プロが見ても、すごいな。一般人が見てももちろんそうなんですけど、こんなことまでできるようになった。
AI also can create a painting. In actual fact, this image is an entirely original tribute to the masters.
クリスさんがちょっと今話が聞こえたかわかんないんですけど、そういうことです。英語バージョン。で、次、色付け。で、これが、結局左の写真の方が、これ昔の、何年前かわかんないんですけど、実際カラーの写真がない時ですね。白黒写真の時代に撮られたものを、今、生き返らせる。色をつける。機械に、マシンに、推測させるんですね、色を。これすごい事実です。だから、なんていうんだろう。もう、おばあちゃんとか、おじいちゃん時代の白黒の写真をカラーで蘇らせることができる。
Colorized pictures with AI, turning black and white photos to color in seconds. Reimagine the past.
じゃあ行きましょう。で、一応今に関連して、デモを行いたいと思うんですけど、コンサーベーターっていうアプリケーションを作りました。で、これどういう意味かっていうと、コンサーベーターっていうのは、絵画とかの修復師っていう意味なんですけど、じゃあ、僕がその絵画修復したかっていうと全然そうじゃなくて、今回写真ですね。たった今見てもらったように、写真の色を、蘇らせる。蘇るともともとないんですけど、当時あっただろう色に蘇らせるアプリっていうのを実際作ってみました。じゃあ、見てみましょう。で、今、これがそのアプリケーションなんですけど、これ、本当にこの時代ってカラー写真多分なかったと思うんです。で、この白黒の写真で皆さん慣れてると思うんですけど、これを今から僕がカラーにします。インチキしてないんで、本当にこれ、バックエンドに送って、API 使って、今から色を。うまくいくかちょっとわかんないですけど、100発やれば、半分ぐらいうまくいくんで。じゃあ、まずやってみましょう。じゃあ次、最初、僕、マリリン・モンロー好きなんで、マリリン・モンロー書いてみましょうか。じゃあ、クリックします。どうでしょう。よし、来ましたね。これ、実際こんなカラーの写真僕持ってなかったですからね。これ、本当に機械が勝手に予想してこのカラーを作り出したんです。もう一個だけ言ってみましょうか。オードリー・ヘップバーン。これももう、この白黒写真有名だと思うんです。これをカラーライズしてみましょう。どうだ？できましたね。若干ちょっと胸のあたりが青くなった分、なんかちょっと殴られたみたいに見えるんですけど、これ多分 AI がちょっと勘違いしたんですね。ということで、ちょっと戻りますね。今回の、私が使ったテクノロジーっていうのが、さっき、ちょっと音声聞こえなかったと思うんですけど、クリスっていうアシスタントっていうのを、これどうやって作ったっていうと、Google のクラウドのテクストトゥースピーチっていうマシンラーニング、ディープラーニングで作られた、API を使いました。で、今お見せした、コンサーベーターっていう、白黒写真に色を加えるっていうのは、ディープ AI っていう API がありまして、これ皆さん使ってくれたらわかると思うんですけど、結構面白くて、どんな白黒写真でも色付けすることができるっていう。あと、ブラウザに使ったのがビューですね。じゃあ次行きましょう。じゃあありがとうございました。一応ここまでなんです。
Hey, come on, bro. Are you kidding me? Have you checked with the audience if they became able to distinguish AI from humans?
はいはい。すみません。今、クリスが、ちょっと、今まだみんなが、僕のテックトークを聞いて、AI と人間を判別できるようになったかっていうのが疑問だと。これをチェックしない限りには終われないって言ってます。わかりました。おっしゃる通り。じゃあ、実際最後に、今映像を見せるんで、その中で誰が人間で、 誰が AI によって作られたフェイクのものかっていうのをみんなテストしてもらいます。いいですか？これが最後のビデオになります。フェイクビデオ、100ビデオ。フェイクビデオ、distinction test。いきますよ。ご用意はよろしいでしょうか？はい。一応ビデオここまで、これで今、一応答え合わせはしないでおきます。中で実は投げ込んでるんですね。フェイクビデオがあって、顔を今交換したんですけど、もし分からなかったら個人的に聞いてください。一応、これが分かれば、今回の AI のテックトーク、聞いた価値があります。で、今最後に使った顔を交換する技術っていうのは、実はリフェイスっていうアプリケーション、携帯で皆さん調べてもらったら分かると思うんですけど、この技術を使ってて、これもただのアプリケーションなんで、僕が実装したとかではないんですけど、まあ、このぐらい技術は発達してるっていうことで、まあ、もしよろしければ、ダウンロードして楽しんでください。はい、これ本当の以上です。ありがとうございます。聞いてくれてありがとうございます。ちょっと最初トラブルだったんですけど、皆さんのおかげで最後やることができました。ありがとうございます。バイバイ。
Okay, Hong-san, thank you so much for the super interesting presentation there. Hong, is that your face? I'm just gonna assume yes, just looking at his picture here. Okay, is it you, Hong?
Thank you.
Yes, great. Okay, all right. So Hong, thank you so much. That was a really interesting talk. As usual, we're gonna take a short break, and the next talk is going to begin at 2:30.
本さん、ありがとうございました。すごく楽しませてもらいました。最後の最後まで。はい。では、次のテックトークは2時30分から始まります。では、2時30分になったらまたここに集まってきてください。では、また後ほど。バイバイ。
Okay, welcome back, everyone. Hope you enjoyed your short break. So next, we're going to be turning over the mic to Noritake Takamichi, who's going to be breaking down the genetic algorithm in simple terms and then demoing a web app that utilizes one.
では、次のプレゼンターは高道則武さんです。彼は遺伝的アルゴリズムについて分かりやすく解説していただき、それを利用したデモも紹介してくれます。では、のりさん、よろしくお願いします。
はい、ご紹介ありがとうございます。それじゃあ画面共有します。では、小学生でもわかる遺伝的アルゴリズム最適化問題入門ということで、高道則武が発表します。ちょっと私について自己紹介させていただきます。私は北海道の札幌市出身で、特技はスキージャンプです。これが私です。で、好きな科目は数学なので、今回はアルゴリズム系のトピックにしました。コードクリサイスに入る前は、SIR の社員を2年間やって、フリーランスエンジニアを3ヶ月間やっていました。で、コードクリサイスに入ったのは、プロダクトをゼロからスピード感を持って開発する経験をしたかったからです。で、CCJ2 で最近10月に卒業したばかりです。で、今回の発表の流れとして、さっきもちょっと AI の話あったんですけど、それにもつながると思うんですが、最初に最適化問題は何かというふうなことを説明してから、遺伝的アルゴリズムについてざっくり説明した後、デモをお見せして、そしてデモで使ったアルゴリズムをご説明した後、応用例をご紹介いたします。まず皆さん、最適化問題って聞いたことありますでしょうか？数学が好きな人だったら結構聞いたことがあると思うんですけど、実際に Google 先生に聞いてみたところ、特定の集合上で定義された実数値関数または整数値関数についてその値が最小もしくは最大となる状態を解析する問題であると出てきました。これだけ聞いても分かる人はほとんどいないと思います。なので、少しいくつか、実際の例を用いて説明していきたいと思います。皆さん、小学生の頃とか遠足に行ったと思うんですけども、遠足にお菓子持ってきますよね。そこで500円までとか、金額のルールがあったと思います。それをイメージしてもらえればと思うんですけども、今回の問題としては、500円までのお菓子で合計カロリーが最大になるように、このリストのお菓子からお菓子を選んでくださいっていうふうな問題を考えます。で、お菓子は何個選んでもよくて、それぞれのお菓子は2つまで。例えばこのスナックを2個入れるとかはダメです。例えばこんな選択肢があると思います。この100円のせんべいと400円のクッキーを選ぶと、1050キロカロリー取ることができます。で、スナックとクッキーを選ぶと450円ですけど、1000キロカロリー。これでも OK です。またこの4つを選んで、1280キロカロリー取ることもできます。このようにいろいろ選択肢がありますね。で、このすべてのパターンを調べるとどうなるかというふうに考えると、このスナック菓子を入れるか入れないか、その2パターンを考えて、せんべいを入れるか入れないか、そうしていって10パターン全部入れるか入れないか考えていくと、2の10乗で1024パターン選ばないと最適な最大カロリーのものを選ぶことができないというふうな計算になります。結構これでも計算量多いですよね。もう一つ例を見てみます。巡回セールスマン問題っていう、ちょっと数学では結構有名な問題があるんですけども、優秀なセールスマンの方がいたとします。セールスマンの方は A の営業所を出発して、B の営業所でゴールだとします。その間にこの13個の家を一つずつ訪問していくという一日の流れだとします。で、この人はあんまり多く移動したくないので最短経路で行きたいと思っています。で、その最短経路をどうやって求めればいいのかという問題があったとします。例えばこんなルートも考えられますし、こんなルートも考えられます。 で、すべてのルートを計算すると、13個の家の順番をどう回るかというふうな問題になって、13の階乗、13×12× って言って1までかけると、だいたい62億パターン計算しなければなりません。62億パターン。コンピューターにやらせたら何時間かかるかわからないんですけども、ちょっと実用的じゃないですよね。そんな時、遺伝的アルゴリズムが力を発揮します。この遺伝的アルゴリズムは、他の最適化の解き方だと微分とか積分とか、そういった複雑な数学的知識が必要なんですけれども、この遺伝的アルゴリズムだと、足し算、掛け算、引き算、割り算ができれば、基本的にはできるということになるので、小学生でも理解できるかと思います。いきなり詳細を説明してもちょっとわからないと思うので、かなりざっくり最初に説明したいと思います。後から詳しく説明します。まずこんなミッションが与えられたとします。優秀な遺伝子を残して、より遠くへ飛ぶ鳥を生み出せというミッションが与えられたとします。でもこれ実際に競馬の世界とかでもあると思うんですけど、サラブレッドとか速い馬の遺伝子をどんどん残していくっていうことは実際に行われていることです。ちょっと今回は鳥で考えてみます。まず最初に初期状態として第0世代の作成をします。ランダムな個体を引っ張ってきて、今回4体集めました。次に飛べる距離を測って評価します。5メートル、3メートル、6メートル、2メートルっていうふうな距離の結果になりました。そこから優秀な遺伝子を残していくために、1位と2位を残すことにします。なので、この赤い鳥さんと黄色い鳥さんを残します。そしてこの1位と2位の鳥さんの子供を作成します。優秀な遺伝子を残すために子供を作ります。そうするとこの子供が第1世代の子供になります。2人できました。そして親と子の4体合わせてまた飛べる距離を評価します。そうするとこの2体が1位、2位になりました。で、これ見てもらってわかると思うんですけど、子供は、この子は8メートルと、両親よりも長く飛んでいますが、この子は4メートルと両親よりも退化してしまいました。このように進化することもあれば退化することもあります。で、より進化したものを残していくというふうな作業をすることになります。で、自然界ではたまに親とは異なった遺伝子を持った子が低確率で生まれます。例えば、このネズミの子供が目が親と違う形になっているということは、自然界でもたまにあることです。この鳥さんの例で考えると、親と違う色を持った、違う遺伝子を持った子供が生まれることがあります。これは遺伝的アルゴリズムでも実際に実用され、取り入れられています。ということでまとめますと、この突然変異をすることによって思いがけない優秀な遺伝子が生まれることがあります。なのでこのプロセスは必要です。まとめますと、遺伝と流れとしては、初期状態、第0世代を作成して飛ぶ距離を評価して、そして1位、2位を選択し、子供を作成して、低確率で突然変異が起こるんですけども、このサイクルを延々と繰り返すことによって優秀な遺伝子が残されていくというふうなプロセスです。じゃあ一回巡回セールスマン問題に立ち返って考えてみましょう。この問題でもいろんなパターンの経路が考えられます。この経路を優秀なものを残していくことによって最適な経路を残していくっていう作業が今回のアルゴリズムのゴールです。で、今回はそれを可視化できるようにしたので、ちょっと見ていきましょう。今回先ほどのように、先ほど鳥が4体いたと思うんですけど、それと同じように4つのルートを1つの世代としました。その中で1つのルートを目に見える形で表示するようにしました。例えば、 5個、家を配置します。この時に青いところがさっきでいう営業所のスタートで、緑がゴール、そして赤が回る家になります。例えば100回で回すとすると、こんな感じで経路がどんどん変わっていくんですけども、これが4つの経路の中でも一番近い経路を表しています。では先ほどのように13件回るケースを考えてみましょう。13件家を配置しました。で、今回時間の関係上5000サイクル、5000世代まで計算することにします。じゃあやってみます。このようにどんどん最適化を目指して経路が変わっていっていることがわかります。ここまで順調に変わっていったんですけど、こうやって時間が経っていくと経路が変わらなくなることもあります。これはその遺伝子の周辺に最適な経路が見つからないときは、ずっと最適な経路が変わらないまま、ずっと世代が多くなっていくというふうな状態で、突然変異が起こると一気に、最適なものを見つけるというふうな流れになることもあります。はい、5000サイクル終わりました。大体ここからスタートして緑のところに行く流れとしては、かなりいいルートになったと思います。実際正解は私でもわからないので、かなりこれが最適だということで、今回の計算は成功と言えると思います。今回作ったデモだと、50件家を配置するとかもできるんですけど、さすがにこれ5000サイクルで収束しないと思うんで、これを収束させようとすると5万サイクルぐらい回さなければいけないと思います。ちょっと時間の関係上、それは省かせていただきます。はい、デモは以上なんですけども、すみません、ちょっと動かなくなっちゃいました。申し訳ございません。ちょっと一回停止させてください。ちょっと待ってくださいね。どこまで行きましたっけ？はい、すみません、戻りました。今回使ったテックスタックとしては、リアクトのみで実装しました。Python に、遺伝的アルゴリズムのライブラリがあるみたいなんですけれども、それはあえて使わないで、ライブラリを使わなくても実装できることを確かめました。で、今回のアルゴリズムをちょっと説明させていただきます。今回、簡単のため8個家を、設置したことを想定して説明します。8個の家の回る順番の定義を左のようにして、4つのルートを最初に作成します。で、4つのルートの距離をそれぞれ計算して、で、1位と2位のルートを選択して、その子供を残します。で、子供の残し方なんですけれども、親の 共通点を残すということを考えて、この青い四角1と3のところは親と子供、両方とも同じ場所に同じ番号があるので、こちらは残して、で、オレンジのところだけシャッフルします。こうすることによって、お父さんとお母さんの共通点を受け継いだ子供が生まれます。で、突然変異の起こし方なんですけど、これはシンプルに2つランダムに選択して入れ替えます。こうすることによって思いがけない最適なルートが生まれることがあるので、このプロセスは必要です。ということで、先ほどと同じように、ルートの距離を評価して、近いルートを選択、子供を作成して、突然変異させるというサイクルを、先ほどは5000サイクルを行って、最適なルートを見つけました。で、より早く最適化を求めるためには、先ほど4つの1世帯ごとに4つのルートを考えたんですけれども、もっともっと数を多くして、8個ぐらいにすると、もっと優秀な遺伝子を残しやすくなるということが考えられます。続いて応用例についてご説明します。こちらちょっと YouTube から見つけたんですけども、マリオを遺伝的アルゴリズムでクリアするというクレイジーなミッションをしている方がいました。これは計算としてはマリオが進む距離を最大化するという問題を与えて、ここに十字キーと AB ボタンの入力があるんですけども、どのタイミングでどのボタンを押すかっていうふうなことを入力値として遺伝的アルゴリズムのサイクルを回していると言えます。3時間でクリアしてしまうらしいです。で、2つ目の例として、これは新幹線のこの顔の先端の形を遺伝的アルゴリズムで最適化したというふうな例がありました。これは空気抵抗を最小化するというふうな問題を解いています。この形状にもいくつかパラメータがあると思うので、そのパラメータを上下させることによって優秀な遺伝子を残して空気抵抗を最小化しているというふうに考えられます。以上まとめになります。今回は微分とか積分などの複雑な計算なしで出則演算だけで遺伝的アルゴリズムを作成して可視化することができました。あと応用例としてはハードウェアを含めて様々な分野に応用可能で、遺伝的アルゴリズムは応用可能です。以上になります。今回のアプリケーション、こちらの QR コードにまとめましたので、ぜひ見てみてください。何か質問があればメールでもリンクトインでもご連絡ください。以上で発表終わります。ありがとうございました。
Okay, thank you so much, Nori. That was wonderful. And thank you everyone for tuning into Nori's talk. So the next talk is going to start at 3 o'clock. So everyone, please take a little bit of a break.
のりさん、ありがとうございました。すごく難しいトピックだったと思うんですが、とてもわかりやすい説明で私でも理解できました。はい。では、次のテックトークは3時から始まります。では、また3時にお会いしましょう。バイバイ。
Okay, everyone, welcome back. So our final talk today will be delivered by Fraser Tooth. We're actually welcoming him back. He graduated about a year ago, so this is pretty exciting. And he's going to be talking to us tonight, or not tonight, this afternoon, about his API project, which is called denkicarbon.jp. So let's give it away to Fraser.
はい。では本日、いよいよ最後のプレゼンター、フレイザーによる、プレゼンテーションになります。今日は彼の API プロジェクトである電気カーボン .jp についてお話ししていただきたいと思います。では、フレイザー、よろしくお願いします。
ありがとうございます。Hello, this will be in English for the most part. Thank you very much for joining me today. Let me just bring everything up. Okay. That's doing the thing. There we go. Grand. Yeah, thank you everybody for tuning in today. So today I'll be asking the question, what color data project? So a little bit about me, just to start off with. I am originally from Scotland in the UK. I majored in electrical engineering, but my kind of career journey and why I'm so interested in energy is that I started my career in building energy use design, like how buildings use energy, consumption. And then I moved from that into energy IoT, Internet of Things, building solutions for smart grids in the UK. When I came to Japan, I had all these plans and they kind of changed quite a lot. And I pivoted my engineering into becoming a software engineer with Chrysalis. So now I'm working as helping out with the foundations beginners classes at Chrysalis. But so I like beer, cheese, food. I love dogs and games and mountains. Obviously, Japan's the perfect place for a lot of that. And today we'll be talking about another thing I love, which is energy. I'm still really passionate about that industry, which I worked in for so many years while I was in the UK. So yes. So today I have a question for you, I guess. More a statement. We're always using electricity, just all the time. We can see that the lights are on in this room. Maybe you can feel that your aircon is on, and maybe you hope that your refrigerator is still running. But do you really think about your energy use? So not really, I guess. We're in a, many of you watching will be in Japan. It's kind of country where you put something in the plug socket, you flip the switch and it's on. Like there's generally no reason to think about your energy use unless it's it's a disaster situation and the energy stops working. There's very rarely blackouts. So we don't really think about it very much, but I guess you might think about how much, obviously, when you use your aircon unit, your heating or your cooling, that can use quite a lot of energy and that, it affects your bill. Nice thing is it's really easy to know how much energy you're using because someone will come round to your house every month or so and will read your meter and will look at the kind of electrical meter outside your house, will tell you how much you've got to pay to the electricity company in your area. So here's the question I have. Have you ever thought about when you use electricity? So why would I think about when? I mean, does it matter when I use energy? Generally, the person who reads my meter only comes around every month. Maybe you have a smart meter. They don't come around at all. But the when, if I use energy in the night and in the day, it doesn't really make much of a difference, does it? Well, there's actually a lot of reasons it does make a difference under the hood. But today we'll be focusing on one reason it makes a difference, and that is for carbon emissions. When you use energy of that electricity. So I'm thinking not about the consuming of the electricity, but when the electricity is generated. When electricity is used, it must be immediately matched with generation. So if a generator, a gas generator in Saitama, generates a little bit of electricity, that is immediately consumed somewhere on the electrical network. There's very little storage, even in Japan, which does actually have quite a lot of storage in comparison to other countries. Generally, energy isn't stored. It's consumed as soon as it is generated. So the when does start to matter because you think about all the mix, the different kinds of electricity. You've got coal and gas, these fossil fuels, but you've also got solar power and wind and other sorts. maybe you're thinking, oh, that doesn't matter. For me, maybe I'm on a green tariff. So some companies in Japan are starting to offer this kind of electricity contract where they say, I know you have 100% renewable electricity, but that's more of a market thing. So, this company will say we have 100 customers and we're going to buy 100 customers worth of electricity on the market, but we're only going to buy from the renewable energy sources. But actually, when you plug something into your plug, in the electrical network, all the energy is kind of mixed together. So unless you're literally pulling energy from your own roof, your energy is mixed in with all the other sources like gas and coal, and as well as the renewable ones like solar. So think about it like this. You've got this mix, you've got some solar, you've got some coal, maybe gas and wind and so on. But at different times of the day, the proportions of those will be different. So maybe the price changes and the gas plant decides, it's not worth turning the plant on. Whereas solar, it's just on or it's not. Obviously the most obvious example of this is during the night, there's not as much solar energy available. Of course, there's none available at midnight. So the other sources will have to pick up the slack to meet the demand of the country at that time. So throughout the day, the mix of things that are contributing to the total amount of energy generated is going to change. Now, in the UK, we have this great tool, which gives us this number, this exact number that says, okay, well, we combine all those energy sources together, the renewable and the non-renewable ones, and we've got this number. And if the number is low, if it's 0, that means completely carbon neutral. And if the number is higher than that, then comparatively more carbon is being generated. Specifically, the value is grams of CO2 per kilowatt hour, which is a measure of electricity. So right now, so this is from my country, the United Kingdom. It's backed by the government, or National Grid ESO. And right at the time I took this screenshot, the carbon intensity was 166. So this is where the color comes in. So the color they have used to describe this amount is kind of an orange color. So it's not green and it's not red. It's kind of, it's okay. Because over the course of the day, this carbon intensity will change. You'll kind of see a graph like this. This is especially prevalent in the UK, which uses a lot of wind. So it's very hard to know when the wind is blowing in different parts of the country. So this carbon intensity values, moves all over the place quite a lot. So, why is this useful? Well, it's really useful because maybe only 5 years ago, the UK's carbon intensity was averaging around 400, but because of this open data, people were able to hold the government to task for their policies. The government says we're going to reduce carbon, and because of the open data that's available in services like this, people were able to say, hey, you should be trying to use less coal because that's a very intensive fossil fuel, and that has actually brought down the carbon intensity by a significant amount over just the past few years. So I think these tools are really useful. It's not just the United Kingdom that has this, it's also all over the world. So this is a tool called electricitymap.org, which essentially combines all these different data sources from various nations and puts it into a world map. So you've got UK up there at the left-hand side, Australia and so on. So the question is, of course, we're in Japan. What about Japan? Well, you might have noticed from the previous graph that Japan, which I centered right in the middle of the screen, has a conspicuous lack of information. It's because they don't have a centralized source of information about how carbon intensive their energy is. So, but it's not like Japan does nothing. They've signed a number of binding low carbon agreements. And very recently, the Prime Minister Suga announced that by 2050, all energy, so not just electricity, will be zero carbon. So the entire country will, for all energy sources, will go to zero carbon. So this is a really great goal. But the question is, how do we know how we're doing if we don't have this centralized data source? How do we know? Well, do we even know right now how we're doing towards that goal? And the answer is kind of. Generally, the different energy companies, so there are 10 energy companies in Japan, like TEPCO, which you probably have heard of if you live in Tokyo. they'll produce documents and reports telling, publicizing how they're doing against these targets. Specifically, the most useful thing, which I've used recently, is stuff like this, which is a graph that shows you today how much solar energy is available. So they'll show you the green line. If you can't read Japanese, it's fine. But the green line up the top kind of shows the demand right now. And the orange line shows how much solar power was available. But the problem is there's this big block there. So maybe at kind of 11 a.m., great, the solar power was maybe contributing about 20% of the energy needs of the Tokyo region. But what about all the rest of this stuff? What's all this? And that's really important because obviously the difference between hydropower, which is really low carbon, and coal is massive. So we need to know what's making up the rest of this gap. Or what about data that tells us what makes up the rest of that gap? Well, you might find a CSV like this, nestled in the website somewhere. The companies will release a CSV like this every so often, which will show you information, very, very raw format about how they're doing. So they tend not to put it into a graph. There's no API available. It's just this raw data. So the question is, well, I guess the problem is obviously no one's going to read this. I mean, maybe energy professionals in the sector will kind of download this and do some analysis in Excel or Python or what have you. But there's no kind of centralized place where all the information is collected together and available. So I built denkicarbon.jp. So feel free to go there right now. Where's your phones? It's open, it's a responsive website, and I'll just go through the project as I have it right now. So I'll reload the website so you can see the whole thing start from scratch. So the API is a bit slow. That is one of the little things I do want to improve. But what it will say, it will go and get information from my central source and say the carbon emitted from electricity generation supplied by the given companies in Japan right now is probably, I'll get onto why it's probably later, it's probably 605 grams of CO2 per kilowatt hour. So that's, it's quite high compared to the United Kingdom's numbers, but we've got a number. So if we look here, we've got a graph that's showing the average. So that's the average over all the data that I've collected from these sources and today's forecast. So I've used a machine learning model to make a forecast for literally today. So November, whatever day it is, the 21st. So this is a forecast for today, November the 21st. That green line at the bottom there is the target. So I talked about the 2050 target, which is like the bottom of the graph. But by 2030, there's another target to get to around about 300, to get an average of about 350 grams of CO2 per kilowatt hour. Okay, so we've got this. So we can compare with different months. So, November, people are using a lot of heating. What about July, when people are using a lot of cooling? Well, it's not much different. How about April, when people aren't using so much aircon? Okay, so you can see that it's kind of more, a bit lower than compared to June, when people start using their aircon. And you can check out other different parts of the country. So let's check out Kyuden, which is in Kyushu. So we remember, so TEPCO was around 650. So give Kyuden time to load up. So we're assuming Kyuden will be quite a bit lower because Kyuden, in Kyushu, the south of the country, they have a lot more sun hours. There you go. Yes, of course. So 427. So they're quite a bit lower on the graph. And you're expecting lower numbers because naturally they just have a lot more solar energy. And you can also compare. So, feel free to poke around the website, and there's a lot of links down the bottom and explanations about the site. And, if you don't speak English, there is a Japanese button right there, and you can swap between the two languages. I'll talk about it later, but all the links to the project are at the bottom of this website. Anyway, so let me get back to the presentation. Oh, I think I need to click somewhere. Grant. Okay, so the problems I've had with this primarily are the source update. The source data is updated every 3 months. With TEPCO, it's actually every 1 month, but that's compared to every 30 minutes in the UK. So in the UK, every 30 minutes, you get the historical data for the last 30 minutes. So this means that big predictions are required. I think people have talked today a little bit about machine learning, but imagine the weather forecast the weather forecast is really only accurate for about a week ahead. Imagine trying to make a weather forecast for 3 months ahead. Hence, it's a probably. I'm able to make a decent prediction for the week after after the new data, the new historical data is released, but after that it's not so great. So that's been a bit of a problem, but it's really the best that we can do. There's also an insufficient breakdown of field types in the data source. You might have noticed on this CSV file, if you notice the Japanese, this bit here, this kanji, literally just means thermal energy. So that's all fossil fuel types, which is coal, gas, and oil. Problem is, coal, gas, and oil have very different carbon intensities, with gas being quite, kind of middle and coal being really, really bad. It also doesn't talk about what carbon capture technologies they might be using. Just the data is insufficient, and the breakdown is insufficient. And actually, nowadays we have batteries, but batteries aren't listed on that source, that data source at all. Also, the source data has a lot of inconsistent formatting, which I'll talk a little bit about more, but that took a lot of time, and occasionally new formatting bugs creep in to the data sources, and I need to handle those. So how did I build this? Coding school, let's talk about the technology behind it. So the API is primarily built with Python. I used the Flask library and an open API spec to kind of define the API. And backing that up on infrastructure is primarily Google Cloud Functions, with Google BigQuery storing the data. And I also use this tool called Google Endpoints, which takes the open API spec that you give it and provides a gateway to your API. So it checks the query before it goes to your Cloud Function, thereby checking that it's in the right format, which saves you some processing time. The website that you'll have seen is pretty simple TypeScript and React, but it's also got uses recharts and uses a translation library called I18 Next. So how does the process work? Well, for the scraper, the system works by just moving my Zoom stuff around. The scraper works by taking the CSVs. They're generally called area data. It seems to be the format. And so the Cloud Function will grab all the CSVs every month. So it's on a little timer. We'll clean them up, do all this cleaning, and send it off to BigQuery. So in Google BigQuery, that's where it does the machine learning forecasting. So I used Python initially because I thought I would have to do the machine learning myself. It turns out that Google has some pretty good boilerplate machine learning tools available. So worth checking out if you're looking to do some machine learning on a large data set and you don't really want to do it locally on your machine. So that's quite good for doing it with Google BigQuery. Part of the problems of this is every single CSV had a lot of different problems. So all these CSVs I'm downloading from the website, even within one energy company, would have varied encoding, random empty columns. So maybe one CSV would be in the right format and the next CSV from the same company would have like 2 empty columns on the side. So obviously you have to be quite specific with your Python scraper to make sure that it ignores those and just gets the data you want. Also varying header length. So sometimes they'd add little notes at the top of the file. So a CSV usually just has the raw data with 1 line of header, but they'd add these notes at the top. Obviously I want to get rid of those, but because it varies, it's kind of annoying. You have to sort of guess and try and detect what your first line is. Also varying file types. So for example, one company wanted to add a hover over tooltip to some of their data. I believe it was because there was an earthquake at the time and they had a blackout. So they one of the file types, so they had a big list of CSVs and then one of them is an Excel file. So you have to sort of handle all these different situations. But because what it looks like is that, I'm trying to build this automated API service. And what I think the companies are doing is just asking somebody to manually upload something they've exported from Excel to the website every month, which, isn't great. And it means there's a lot of work to do on the parsing side to make sure the data quality is good. On the API side, once the data is all safely inside BigQuery, it's pretty simple. So there's a GET request made to the endpoints, which are defined by this open API spec. Has to be version 2, by the way. That checks the query, makes sure it's in the right format. Then we'll forward it on to the Google Cloud function, which goes and makes the request to BigQuery for the data, and then kind of goes back. There's a little bit of reformatting before it goes back to put it into the format to match the specification, and then it gets sent back to the user. So the website itself is just React and TypeScript. And I use Vercel. Pretty cool if you're doing a hobby project, because every time you make a pull request to your master branch, it'll create a preview deployment, so you can check the website online before you push it through to master. So you don't have to, you get these preview deployment websites for nothing, and it's a really cool little feature. I think Vercel is really good for hobby projects because of that. I've also found this tool, React IAT Next, really interesting. So here's an example of where I found it really cool. So it does translation, great, but I wanted to do these inline menus. So think about these two sentences. Today's carbon intensity forecast compared with November. So the menus at the end of the sentence, and in the Japanese version, the menus in the middle of the sentence. So you wonder, okay, well, I could maybe do some classic JavaScript string manipulation and just kind of make it work. Great. But what if you then had this? So you wanted to make a menu for the number of years. Well, in the English version, the 4 years is in front of November, but in the Japanese version, 4 years is after November. So how do you make these inbuilt components change on the basis of the translation? And React change location depending on the translation. And this library provides this really cool thing where in the translation, so there's my carbon graph title translation for English, and you put this little HTML style tag in the translation. And then when in your React, you call this trans component. And you say, okay, here are some components. So take month menu and stick it inside the place in the translation where you've put this HTML tag. And that's really allows me to do these sort of inline menus without really caring about location on the basis of translation. It's just in a translation file, and I could add more languages without too much hassle. Okay, so how can I use this color? How can I, now we're using your API, I can find the color of electricity, fantastic. How do I use it? Well, here's some examples. National Grid ESO, the people who make the UK version of the API, have released an application for your phone, so you can just download that. And that's you can see all the information that comes from the API shown in a really nice format. Okay, that's a pretty simple usage. You can just maybe send that information to Twitter, literally just display the information from the API. Or maybe you can do something a bit more clever. So a company in the UK called Octopus Energy built an Alexa bot. So you say to Alexa, how green is energy right now? And Alexa will respond saying information about the energy mix currently. So you could use that and say, I'm about to do my washing. That's an energy intensive thing to use. Alexa, how green is the energy? Well, the energy's kind of not green right now. And you go, okay, maybe I'll wait an hour and see if it'll become more green later on in the day. Because, maybe it doesn't matter to you when you do your washing, but if you do it at a different time of day, you could use less carbon. And that might be a cool thing for you to do. And it's kind of built into Alexa, so you don't need to use an app or anything. On the bigger scale, Google moves some of their data processing operations to different times of the day, depending on the amount of renewable energy that's available. They use the API that's behind that electricitymap.org project I showed you earlier in the presentation. And that's really cool. Obviously Google has a huge amount of data centers, and they're doing a lot of data processing, like photo, machine learning. I don't know if you've ever used Google Photos. You type in dog and it'll find you all the pictures in your Google Photos that have dog. So obviously they're doing a lot of processing in the background, and they don't care when, they just got to do it at some point. So they might as well do it when the carbon intensity is low. And I think that's a really cool project. On a smaller scale though, something that humble developers like me might find a bit more grounded will be something like this. So I was looking around for examples, and I found this really cool project where this website called climateaction.tech, they have a blog, and they built a blog to change on the basis of the carbon intensity. So the blog, if the carbon intensity is low, there's lots of renewable energy, they'll provide the high quality images on the website. So using the maximum amount of data. Whereas if the carbon intensity is high, so there's not so many renewables, they'll send you a really low quality version of the image, thereby using less processing power on your machine and thereby using less carbon. I thought this was a really cool idea. It's kind of passive way of ensuring that you minimize the amount of time wasted on someone's computer, but also minimize the amount of carbon. I think, I wonder whether as developers, we should start to consider this a bit more when we build tools. Okay, so why am I building this? Well, currently, Suka-san has made his goal 2050 carbon neutral, but really, reality is that we'll probably slowly move towards that goal as a society without making any large drops. But I think with open data and being able to build innovative products on top of open and available data, you can turn that line into something a bit more like this, where you approach a lower carbon much, much faster. And you can make the quick wins early when it's visible and obvious what you have to do. People don't know when the energy is green. So how about using tools like this, we can help people understand, and hopefully we can move towards a lower carbon Japan much, much faster using these kinds of tools. So please try the API out. All the information is on denkicarbon.jp, repo, doc links, and etc. are on the bottom of the site. In fact, I did forget to show you, but the docs link is really cool because it's in Swagger Hub. And on Swagger Hub, you can generate your own SDK for the API. So here's all the information. Here's all the different things you can ask it for. And if you go up to the right-hand side here, export client SDK, you can just download a Node version of how to call this API without having to build any of it yourself. So Swagger is pretty cool for that. So yeah, please do give it a go. Try it out for yourself. Whack it into your browser and see the data come back. And yeah, let me share it with your friends. Let me know what you think. And most importantly, I just opened it today, right at the bottom of the website. Please click this link, Slack community, and join the Slack community for the project if you're interested in finding out more about it or helping out with the development. It's entirely open source development, so I'd love help with the contribution help if you're interested. Grand. Thank you very much. And thank you for listening.
Okay, Fraser, thank you so much for returning and doing another tech talk. That was really interesting, and I think that information was super, super useful for everyone. And please do contribute to Fraser's project and help us, get onto the path to being a little bit more sustainable. So I want to close it out by saying, thanks so much to everyone who tuned in this afternoon on a beautiful day like today. And congrats again to all of the graduates who have returned and put in just so much effort to share this information with all of you today. And to everyone in the CC community, please take care of yourself, stay safe and well, and we'll see you all again online at the next event.
はい、フレーザーありがとうございました。今日はこの晴れた土曜日の午後、コードクリサリスのビッグミニコンフにご参加いただき、皆さん本当にありがとうございました。そして今日の日のために素晴らしいテックトークの準備をしてくれた卒業生の皆さん、本当にありがとうございました。それではまた次回のイベントでお会いしましょう。素敵な週末をお過ごしください。さよなら。
バイバイ。